I'm just going to go through very, very quickly the methodology for the assessment of the inundation risk and also, hazards and the assessment of the coastal erosion hazards. And then really the outcome of that is coastal hazard mapping. So I'll just bring those up and we can just have a quick discussion about what that means. We can discuss in detail after the presentations and after the forum tonight if need be, but I think in general the plan is to keep it quite overarching as part of this process tonight. So we've already been introduced to State Planning Policy 2.6, but I think the key thing to note out of it is that whilst it in some cases is typically used for guiding the development of new infrastructure on or near the coast, it's a very useful tool and has been developed to help basically quantify risk for existing development and outline what sort of risk management strategies may need to be introduced to combat the risks that are posed by these coastal hazards. So in saying that, it requires consideration of very severe events. We obviously don't design things for events that happen all the time because then more than likely things will fail. So when we talk about very severe events, for inundation, we're talking about an event that has a 0.2% chance of happening every year. So 0.2% chance of happening every year also means that if you looked at a really long time period, on average it would happen about once every 500 years. So it's a very severe event, but like I say, there's a reason for that. When we're looking at coastal processes or coastal erosion, we look at an event that has a 1% chance of happening every year. So again, using the same terminology as before, that could happen roughly on a long term once every 100 years. So also in terms of coastal erosion, we need to consider other impacts. So we look at things like the response of the shoreline to ongoing change from sediment transport, so long-term factors and what may happen into the future. And we also consider the effects of sea level rise and what that may mean for the shoreline, and particularly the shoreline response. So the two assessments that we've completed to date for Point Moore and also for Town Beach up to Drummond Cove, we've considered a variety of timeframes just to help inform that future risk assessment process and the adaptation timeframes that are required to basically ameliorate the risks associated with these. So we've considered present day, we've considered also the year 2030, 2070 and then 2110. In terms of inundation, very, very briefly, there's three different types of inundation that we need to consider. So we consider in Geraldton, cyclone inundation, because Geraldton is affected by cyclones. We consider your non-cyclonic inundation, so the storm surge that occurs as a result of south coast storm systems, so cold fronts and the like coming through Geraldton. And we also consider tsunamis. But when we consider tsunamis, I guess the work that we've seen really indicates that tsunamis are and their impact on Geraldton are beyond the 500-year average recurrence interval event and therefore aren't really the dominant feature in terms of inundation. So when we look at all of these, we basically also have to consider what's happening to the sea level over the planning horizons that we're considering. So this plan, Mike referred to it before, but this is what the current state coastal planning policy is based on. So this is the projected sea level rise allowance that needs to be incorporated into coastal planning in WA. So starts out obviously at current sea levels. When we get towards 2110, we need to provide an allowance of about 0.9 of a metre. So we're accommodating a 0.9 metre rise in sea level over the next 100 years or thereabouts. Just in terms of inundation, so the key thing is that for Geraldton, when we're looking at the severe events, they're dominated by cyclone events. In terms of coastal processes, as I've said, there's a few things that we need to consider. So we consider an allowance for storm erosion. So we have a storm that comes through and obviously it can cause erosion of the coastline. We consider the long-term shoreline movement and how that shoreline movement is expected to continue into the future. So to do that, we look at historical records and we see if there's been other impacts on the coast, such as development of or construction of marinas or ports or that type of thing. And we try and assess what may happen into the future. And we then provide an allowance for shoreline recession. And that allowance is based on an application of a thing called the Broome rule. So very simply, what it says is if you have a rise in sea level of 1 metre, you'll have 100 times that, so a 100 metre recession of the shoreline. So when we're talking about that 0.9 of a metre of sea level rise to 2110, we're allowing for a 90 metre recession of the shoreline. So that's part of what you will see in the coastal hazard mapping that we'll present. There is also an allowance for uncertainty. Obviously, with all these things, there is uncertainty in them, so we provide an additional allowance for uncertainty just to make sure that we have some safety or some additional safety there in those numbers. So, in terms of what it means, the outcomes of those studies basically come up with a whole suite of different maps which show potential risk. So these are the plots for inundation. The detailed plots are all presented in the reports that are on the city's website. But just to sort of talk you through what they mean, all these plots are for this that I'm presenting tonight are based on the year 2110. So this incorporates a 0.9 metre rise in sea level. There's other plots that show present day 2030 and 2070 as well. So what it basically means is that in 2110, anywhere that's shaded purple would be inundated during a 20-year average recurrence interval event. So an event that happens on average once every 20 years. The additional area that's shown in blue indicates the area that would be inundated during a 100-year event in 2110. And the area that's shown in green is the same, but for a 500-year average recurrence interval event in 2110. So you can see, not surprisingly, it gets worse from the 20-year event to the 500-year event. And also, if I put up the present day plots, you would see that it gets worse as sea level rises as well. So there's nothing startling there. The key thing is to look at the areas that are actually potentially affected at these times. And they're the areas that really the coastal adaptation process, so the next steps in this process, need to consider and determine what's the response going to be to these hazards. So that's inundation. In terms of the coastal erosion or coastal processes allowances, we come up with distances from the shoreline. So it's an addition of all of the different factors that I've outlined before. And again, just to go through it very briefly, we have a present day risk, which is largely just a storm erosion risk. So it's a 100-year storm. If it happened tomorrow, what's the area that's potentially at risk? We then have a 2030 line, which incorporates some allowance for sea level rise to 2030, as well as the long-term shoreline movement trends. 2070, much the same, except to 2070, and then so on for 2110. So basically, the way that you read these plans is anything that is seaward of those lines could potentially be vulnerable at that time frame.